Last time we looked at query optimization, and now we look back a little bit at IMDb. So this application I showed you initially when we started this lecture, and now we do a third part of that actually. So I changed this general structure I introduced early on. So initially we said, okay, we looked at data management issues mainly, but today we will also look a little bit at security and web development issues. And you could argue here that's the other guys, security experts that will look at that. There are web development people that will look at that. But hey, it's not so easy because what you do as a database developer may have ramifications on those levels as well. So you should be aware of certain things. So very prominent security problems. I will introduce the most prominent one today, later on in the second half of the lecture. But I also will give you an idea today about web development in general. So databases are just one layer, as we call it. You will see it in a moment when developing an app. Yeah? So if you develop an app like for a smartphone or whatever, for a laptop or for a server, somewhere in that huge stack of software there will be a database management system. But there are many other pieces that are there, and I will give you some idea about those other pieces and why that is actually super interesting to look at these things. Okay, so again, that's what I showed initially, that IMDb web page. I'm not sure whether there's an app for that, but basically web page is already very involved, and there's a huge database behind that you can use to look up all kinds of information about movies and TV series and whatnot. Yeah, and there's a movie called Django Unchained, and today actually it's also about Django Unchained, but not the Django from the Tarantino movie, but the Django which happens to be a software project that's super cool, and it's based on Python, of course, and I will give you some glimpse about Django. If you haven't seen the movie, by the way, you should also watch the movie, but if you haven't seen the Python project Django, you should also take a look at that. Right, so when you develop a web application or any application, or also an old term for that is information system. Actually, my group initially when I joined Saarland University was called information systems. Yeah, it's kind of a very, I don't know, vague term, hard to understand what it means. But the idea is you have a system that you can interact with. You can put in data. The system returns your data. So in the wider sense, almost all software is in one way or the other an information system. Yeah? Be it any system you use to whatever, collect your grades from the university or store any parts of information. Even Google could be considered an information system in a way. And what we do in computer science is we organize these systems into stacks, into certain layers. And that's what you see here. So basically, you have those layers here. And there's a user using the system through whatever means, laptop, smartphone, whatever. And there's an application, basically a pile of code that it does the stuff that you want the application to do. And then underneath, there's a database system, and the application talks to the database system. That's what these arrows here indicate, basically. Yeah? So the application will send SQL commands to the database system. We're not expecting the user to send SQL commands to the database system. There are also systems doing that. Yeah? There will be systems where users send SQL commands, but it's clear that's more advanced user, computer science student, whatnot. So the standard user will not send SQL commands. That's up to the application to generate SQL and send it to the database system. In turn, the database system sits on top of a file system. So the database system will store its data on a file system, which in turn sits on some hardware. But the interesting thing here is that those layers are shielded against each other. So the idea in a layered architecture is that this application only talks to the database system and not to the file system. Yeah? So this shouldn't happen, or there should be a good reason for doing something like that. So the application should only needs to be aware of the database system. Questions? Yeah, and so forth. So the operating system should talk to the hardware, but the database system should not talk to the hardware, and so forth and so forth. And this is a very textbook-oriented, like a view from the past, from the 90s. That's how you would see it in textbooks and maybe some web applications. And of course, reality is more complex. So here in this graph, you see there's a huge application, a big block, a monolithic application doing all kinds of stuff. So this is doing application logic, this is doing front-end logic, many different things. So what you do, or what people do typically in those applications, is split that up into more layers. So you split it up into a user interface, UI layer, and here you have application code written in JavaScript, PHP, for instance, so JavaScript can run in the browser. So most web pages today run some sort of code in the browser. Yeah? It's very rare that web pages don't do that. And then what remains is kept in that application layer. You see it here. Yeah? So that's everything except the UI stuff. And of course, you can split it up further. You could say, and that's what we will be looking at today, yeah, this nesty SQL, it's kind of weird. I mean, if you think about SQL, we have these flat tables with rows and columns, and that's not a good match to programming languages. Programming languages typically have some sort of object-oriented approaches or methodologies, and if you fiddle around with SQL in your application code, basically that's what you're doing here. Yeah? If you have something like this, what this means is you send SQL commands to your database system, then you get some tables returned, and then from those tables you still have to create objects, instances in Question? Haben Sie eine Frage? Then please stop talking. So instances in your programming languages. Yeah? And to remedy that situation is you add another layer. Yes, you say, okay, the application is not supposed to talk directly to the database system. The application will talk directly to something that's called the ORM, the Object Relational Mapper. And that will do all the magic in terms of sending SQL commands to the database system. So an application like this, the application does not issue SQL commands, but the application speaks a different language, that speaks a query language that this layer understands, and then this layer again translates it to the database system. So if you remember what we had in the earlier lectures in big data engineering, I always had another slide saying, oh yeah, we use another level of indirection. Yeah, there's always room for another level of indirection. Yeah, here's another one. Yeah, we don't work with SQL, we work with something I will introduce today that will shield us from having to use SQL in the first place. And that's called object relational mappers. And that makes your life so much easier in development applications. And it also has another benefit, and that is something you must never forget. You avoid a big security issue. The security issue is called SQL injection. I will explain that later on. So whenever you read something on the web that some system was compromised, that some database leaked, that data got available on the dark web or something like that, it is, I would claim, in 80% due to SQL injection, which is super easy to run into this trap. And you avoid that for free if you use an ORM. So just by using an ORM, problem solved. You never have SQL injection ever again. Yeah? And that's a huge benefit of using an architecture like that. So no worries anymore with respect to that. Here, of course, we split it up even further, so there are more layers. So you have an ORM, okay, to wrap that, but then you could also use frameworks that allow you to develop web applications easier. So if you have a back end and the front end, back end always means that's the server running somewhere in the cloud or in the basement, and there's a front end, and the front end code is running on your machine, on your browser typically, yeah? Or even a dedicated application on your client, but not on the server. Now that's this back end, front end separation. Yeah, more splitting up. That's another version of that. Here you could say there's a back end application and there's a UI application. So you could split up your application code and stuff run on the server, and application code that's run on the UI, that runs in your browser. That's actually also something we do in our master application system we're developing. So you end up with all of these layers. And yeah, what's the flip side of having, what's the pros and what's the cons of that? Any idea? Maybe close the door. Can you imagine? Yeah?
Since the different layers need to talk to each other, maybe there's performance issues?
Yeah, indirection always has a potential to ruin performance. Yeah, the more indirections in general, you lose performance. Also, it's similar to these translation steps we did. There's always opportunity to lose information when translating. Lost in translation, it's like the German game Stille Post in a way. Yeah? So the initial intent, yeah, so whatever the user does just clicks on the UI and that's translated. At the end of the day, the database system only sees a couple of SQL statements, but has no idea what the heck is the semantics behind that. And maybe it's losing some optimization opportunities. Yeah, that's very good, right. Any other ideas, what you gain or what you lose? Yeah? Again?
Like by splitting those categories into different costs.
I'm not sure what do you mean. What do you mean structure?
Such that one category doesn't have to handle different, I don't know, different tasks.
What do you mean by category?
Like the different, the UI application, backend application, and so on. Like
Now those are examples and those are really layers. Yeah? And each layer has a certain task that it handles. I wouldn't call it category for the moment. Yeah? I don't know. Yeah?
If you divide your application into layers, you have different opportunities to scale horizontally. For example, you got
Yes.
UI application is just a single page application, just needs once to be delivered and doesn't need much performance
Yes.
afterwards, but the backend needs to do a lot of stuff. You can tie up with the backend instance, for example.
Yeah, very good. That's already a lot of information. Single page application, he said. Single SPA. I saw that recently in German. It sounds like spa, yeah, getting a massage or something like that. It's very weird. SPA, a single page application. That means that you load the application once in the browser and everything else is just fetching data from the server. You're not loading a new web page in a way. You just load an initial web page, the single page application into your browser, and then it's all about fetching data. How that works, we will learn later on. Yeah? That's a fixed term in web development. And the second, he said, scaling. Yeah, that's a super cool thing you have with something like that, because now on every layer, I can say, why would I use a single database system? I can use 10 of them. Yeah, and I can even shield it from the layers on top. Yeah? I don't have to tell the OIM that underneath I have so and so many database systems. So you can even hide that in each layer. You can hide whatever, even for the database system, you could hide that there's a super distributed file system underneath. Yeah? So with extra tricks. It's more something of the core lecture. We will look at that in more depth. It's also called elasticity, if you ever run into that term. Elasticity referring to you have a certain computational demand and you build the application in a way that it is elastic in the sense that once there's a higher demand, it automatically scales up or can easily scale up to use more hardware, to use more resources. And if you have less demands, you can automatically scale down the application. If you build your application in a way that it is elastic, yeah, that's a huge game because then it can scale like crazy. Yeah?
Maybe to catch up with the point that I thought was mentioned earlier, having experts for different kinds of categories. For example, you got one person who builds the servers and has experience in that.
Yes.
The next one looks at the database and can decide what file systems to use because they are.
Yes, excellent answer. That's another thing you see in these teams. You can have certain people focusing on certain aspects. The database guy only looks at the database system. There are UI experts that are good in hacking, whatever, Vue.js and whatnot. There are tons of these web frameworks. So people can specialize on these things. So is that good or bad? Yeah, you have to add another comment.
Each layer can basically be exchanged in logic. For example, if the backend application is running in Python right now, but there's performance benefits in Rust, we can just change the backend application. Basically.
Yeah, true. Be careful with the term, you can just change the backend application. That's a bit of marketing fiction that also happens in SQL and databases. So one idea of database systems was to have a standard language called SQL. Yeah, and once everybody agrees on that language, you can easily exchange the layer. Drop Postgres and use Oracle or something like that. So what did companies do? They introduced special statements that would only be available in their database systems. Application developers started using them more and more and more. So when you now wanted to switch the layer to a different database system, you were completely screwed because you were dependent on these specific features which were only available in whatever Oracle, for instance. Yeah? So that's the marketing strategy from a technical point of view. And it's also something to look out when organizing these layers. Make sure that they're not specific to the concrete system you're using underneath. Yeah? They should be independent of the system. And if you're in that game, then you're right, then you can do that. Yeah? But something to look out as an architect, hey, it's really some super duper feature from the database system or from that framework I'm using. Do I really have to do that? Maybe I want to switch eventually. Yeah? So in theory, it's possible. In practice, might be hard. Yes, very good. But we were talking about this one person, one layer argument. Anything about that? Yeah?
Since it's all in smaller units, there's a lot more communication between them. There's also a lot more attack area.
And there's a lot more what?
Attack area. So because you can attack each system individually as well.
Mm-hmm.
You could intercept the communication, for example, or try to just focus on attacking one system.
You mean one layer? Okay.
Instead of like the whole big block.
Okay, because if you have, as you have more APIs and more visibility, this actually can be made more difficult by wrapping each layer into a Docker container and then allowing just certain types of accesses. Yeah, so that's a mitigation strategy you could use. But in principle, you're right. Yeah? If you don't wrap it into Docker containers, that's correct. Yeah, but I was alluding to something else. If everybody says, I don't care, I do the database stuff, whatever you guys are doing above, I really don't care, figure it out yourself. Yeah.
Constructing a layer, you still have to talk to the other people who
yes.
are in the other layers
yes.
to make sure that they're interoperable.
Yeah, yeah. Right, that goes and that points in the right direction. Any other comment? Yeah?
There's a lot of efficiency in general. If you have all the communication between the different systems and nobody kind of has the overall big view of how it works.
Yes, yeah, that's a very important thing. There should be people that have a wider view on the system. More than one layer, ideally multiple layers. Those people are also called full stack developers sometimes. One example from what we will, what you can see when you have this Django backend framework, what we bumped in, for instance, was that Django at certain occasions created many SQL statements, and not Django, but the ORM actually. Yeah? The ORM created many SQL statements, and as a database developer, you could say, that's not my concern. I get a SQL statement, I optimize it, see the last 2 weeks, execute it, and yeah, here you go. That's your results. Yeah, that could be the attitude, but actually the number of queries created by the ORM indicated to a problem in how people used Django, in that particular case, Django ORM. So if you understand that, and if you understand what Django is doing, you can talk to the Django developers and say, hey, we identified that. Actually, it's a well-known problem. It's called the n+1 query problem. If you do this and that, you will only be sending one query and not hundreds of those. Yeah, so you solve a performance problem. You solve a dramatic performance problem. It makes a huge difference in the system. Yeah. So having layers is not an excuse just to look at individual layers. Okay. Yeah, we have a little example project. Where's my glasses again? A little example project that you can use to kickstart understanding what the Django is about. It's basically a web page where you can now look at individual movies. It's the exact same subset of the database we used in previous examples. And that page creates a couple of entries like, okay, those are the movies. And it also shows you the SQL queries created underneath in the layer. Yeah? So you can always look at, okay, that is a SQL that was issued by the system. So, but how does that work? So there are different types of ORMs, object relational mappers, and I will focus on Django ORM. But as said before, the ORM shields the application developer from the database. It allows the application developer to define an object-oriented schema. So you don't define the standard create table SQL schema anymore, but you do something different. You can query for objects in the schema. So you don't send SQL, you have somehow different query language, and you can insert, update, and delete those objects, not through SQL, but through other calls. So this is much easier from the point of view of an application development, and you don't have to mess around with SQL, and again, automatic protection against SQL injection attacks. I think you can use ORMs as well to still have SQL injection attacks, so it's important you understand why the ORM shields you from that. So you can still screw it up if you want. Yeah, that's again the repetition that we are hiding another layer. We can introduce yet another layer. So I mentioned that before. We can skip over that. Now we will be hiding a SQL. And so we had relational algebra. We put SQL on top. Yeah, and then we had the question, how do we get from SQL to this relational algebra or to physical plants? That's what we looked at the last 2 weeks. It's a query optimization problem. That's about translating SQL to plants, relational algebra style plants. Now what we're looking at is translating from query sets. That's a query language the ORM uses, the Django ORM uses, to SQL. How is that translated to SQL? It's kind of a higher level query optimization problem, but actually there's not so much optimization happening because basically we're using a different syntax. It's basically the same thing, so the space for optimization is not so big. So how does such a schema look like? It's basically, when you look, what you do is you create this object-oriented schema, OO schema, and that's a set of models. Each model is basically like a table in the SQL world, in the database world. Yeah? And each model comes with a class definition that corresponds to one relation in the relational model. And these models are defined in a file called models.py. So for instance, the relational model that we wrote as something like that corresponds to the model like that. Yes, it's basically rotating it by 90 degrees and putting each attribute on a separate line. That's the same thing. So this model is called movie. It has a couple of attributes. Here you always have to say models dot and then the type. That's defining the type. So that's basically corresponds to this here. Yeah. That's it. It's just syntax. If you don't specify the primary key, so the key of the model as the key of the relation, Django ORM will implicitly create an attribute ID. So even though so here you will see that effect. There's no primary key marked in any of the parameters. You could always say in a parameter like, if you wanted to do that, the year should be a primary key. Semantically it doesn't make sense, but you could do that. Primary key equals true. Then that would become the primary key. However, there's no primary key here specified, so Django will implicitly create another attribute called the ID, so an artificial ID. Yeah, then there are what happens to N-to-M relations. Those intermediate tables, if you remember, whenever there was an N-to-1 or 1-to-N or 1-to-1, we didn't have to create an intermediate relation. It's not necessary because you can change the attributes of the participating relations in a binary relationship type. But here, in an N-to-M relation, you have to create this intermediate table. That is called a through table in Django language, and that is created automatically. You can still also write it explicitly. For instance, if you want to add attributes to the through table, like in IMDb, an actor having different roles. We had that example. But if you don't need that, it's created automatically. Here's an example for something like that. So Here you see this is a many-to-many field to genre, and you don't have to create the intermediate table manually. However, if you want to do it, you can also do it. That's the example we had here. Initially, so there's movies, this is a many-to-many relationship, and you say, yeah, but I want to add an attribute, so, and then you say, okay, the through table is called play in. So I now used table and model as a synonym, yeah? You notice already. And that's basically then defined here to say, okay, that is this model play in, and that is the through table. You again specify the foreign keys to the two participating relations, so it's kind of redundant, but that's how you have to do that. And then you add another attribute here, this role, Peter Sellers. We had that example specifying the role for the specific relationship. That's basically all you do. So it's basically syntax and conventions, you have to learn about that. Yeah, for keys, so you don't have to specify a key attribute. Django will implicitly create it. However, you can also mark an attribute to be a primary key. Here you would say the abbreviation is the key. So this is a model reflecting grades in the system. And then I would say, okay, that becomes a key. Then it's unique, and that key will be used also for foreign keys referencing that. The downside of that is a little bit that you can't have composed primary keys in Django. So in standard SQL, you can say the primary key consists of attribute A, B, C. That's my primary key, so the combination of the attributes is my primary key. That's not possible in Django, unfortunately. It's kind of weird sometimes, but that's a constraint the system has. Yeah, there are a couple of shortcuts. So there's this PK attribute and an implicit attribute. So in Django, whatever was defined to be the primary key for a model, you can simply refer to it using the attribute PK. So you don't have to know what the attribute is. You just say, if you have an instance of that model, you just say grade.pk, and that's a shortcut for grade.abbreviation in that case, yeah, for this one. That would be the normal way of referencing an attribute of an object. This is the object, that's the attribute of the object. It's standard dot notation, but you can also say that because that was marked as a primary key, so that might be handy sometimes. You also have unique constraints, so you can constrain groups of columns to be unique. This can also be used as a workaround to simulate composite keys, again, which are not supported. And this is done through the nested, through the subclass meta. So you can, for these models, when defining that, you can write class meta column, and then you can add a couple of constraints here. There's a long list in the Django documentation what you can do there, and many tricks you can play. But in terms of modeling, what I'm doing here is I'm saying, okay, whatever actor, movie, and role should be unique. And when you write it like that, and the Django ORM will make sure that this unique constraint is reflected in the underlying database. So it will be implemented by the ORM automatically. You can also say, no, my database table should be named like that, and the database stuff like that, and many other things you can do there. Yeah, and then that's kind of important to understand. Now you defined your model. If your model's py, class, foo, colon, whatever. And then what you do is you still have to translate the model to the SQL model. And Django is doing all of that for you. And there are two commands that you have to understand there. One is make migrations, and the other is migrate. So in Django, there's this manage command, and that's super useful to manage the server. You use that to run the actual server. You can use that to run your unit tests. You can even add your own manage commands. It's super useful. But in terms of the data model, what you need to do is you have to make migrations. Make migrations means that Django inspects the model's py file and tries to find out whether there are any changes that should be applied to the underlying database system. So if you start from scratch and have your classes, by making migrations, Django will try to understand whether you have to add tables or attributes to the database schema. Yeah? So basically all you need to do when fiddling with a model's py file is call this this command, and then call that command. Migrate will apply the migrations to the underlying database system. The cool thing here is when you mentioned that this is database system independent. Yeah, Django works on all kinds of database systems, and these migrations are database system independent. Yeah, maybe I show migrations, and it's easier to understand. Where is that? Templates here. That's an example. Can I make this bigger? Maybe I don't need this one. So that's a migration. That's you see that this has a number here, underscore initial. That's the initial migrations being applied, and basically this is a database management system independent way of specifying the schema. So this is another abstraction layer that's independent from the concrete database system, and those files are created when you call make migrations. Yeah, so you can write migrations files manually, but you shouldn't do that. So the Django ORM will generate it for you. Yeah? So these files are created, and then when you call managepy.migrate, the migrations are executed against the specific implementation of the migrations for this database management system. So this is super cool because it means the migrations generated by Django are system independent, and now every database system can have an implementation to map those system independent migrations to the specific system. Yeah, that's a super cool way of doing that, and very useful. And you just have to be aware when fiddling with the database schema, you have to work with these commands. And there are some learning curves with these commands. So the idea is that you modify only the models PY schema, but not the database schema anymore. So you only change the schema at one point, not at both models PY and the database system. No, only at models PY. That's one way of doing that, and that's called a managed database schema. So Django manages the database schema for you. But you can also do an unmanaged database system, unmanaged database schema, and that is this one here. And then you set manage to false in the meta subclass, and that means that the migrations will ignore this specific model. Yeah, so if you then change anything here, you also have to change it a second time in the underlying database system. This could be useful sometimes if you have weird quirks with the database management system, maybe some API error or whatever, some weird situation you feel like is a great idea, but typically you don't do that. I wanted to, also it's bootstrapping, yeah, that comes later. Yeah. Yeah, maybe I might jump over that slide directly and go into this one because this is pretty useful. So you could also do, you can do that in all kinds of directions. Now what I showed you before was you create the models PY and you create the database schema. But you could also start from the database schema. So that's what we did for our master application system. For instance, I'm a relational database guy, so I created the database schema, and then I found out, oh yeah, but I need the models PY. You can generate the models PY automatically from an existing database schema, which is super cool. If you already have a database system with a schema, all you have to do is call this command. Yeah? Inspect_db is the manage command, and then the output, you send it to your models PY. That's it. Here you go. Yeah? I think by default, the models are then set to unmanaged, so you might have to set them to managed again. I'm not sure about that. A long time I used that. But basically what it allows you to do is something like this here. Is you can do good old relational modeling as learned in this lecture. You refine your model, refine it even more, refine the model even much more. Eventually say, okay, now I make the step to developing the Django web application. Then you run this command. You set all models to managed in Django, and any future schema change will only be done in the models PY, in the Django or ORM only. Yeah? Then you change in models PY, call make migrations if you changed and migrate, yeah, but you never touch the database system anymore manually. Yeah, that's a very good workflow I can recommend. Okay. Yeah, for completeness, so in the meta class, you can define many things. You can set constraints, indexes, unique together, ordering. You can give a name to the database table, or you make it even abstract and say, yeah, you shouldn't instantiate models from that class. But for abstract superclasses, for instance, that's very useful. So this is a Django application. Yeah. So if you click here on that basically shows you information about those movies. And so if you click on any of those IDs, for instance, then you see information about that movie, actors and whatnot. And you also see the SQL query is being issued here underneath in the stack. Normally you wouldn't return that to the web page, of course, but that for to learn about these things, you see that's the SQL statements being created by the Django ORM, and that's the data being returned. And here's also the number of queries issued by Django ORM. And that's basically all we do. So we want to understand how do we create a web page like that returns somehow data from the database system that also will allow you, of course, to update data, insert data, and stuff like that. That's basically what this lecture is about. Okay, and we were talking about the different schema aspects of that. And now we look at the query language as promised. So Django comes with a separate query language that's called query sets for whatever reasons. Where's a pen? Right. And so, for instance, a statement in that language could look something like that. So it has an object-oriented flavor. It typically starts with the name of a model. Maybe I make it a little bigger. The name of the model, and then dot objects, and then dot something. Here, dot filter means, okay, that's like a where clause. You want to only have those ones where the year attribute is greater equal 1999. So it's not year greater equal 1999. It's year underscore underscore GTE equals 1999. This is ugly, I know. I didn't invent that. I'm just the messenger, okay? Yeah. So the language is really weird at times. There's a learning curve and there's a having get used to that. I'm still struggling with that. And then, of course, what you could also do, you could send SQL queries. Yeah? There's always, for me, I had multiple occasions throughout our project to say, I'm really fed up, I will write a SQL query. And you can do that in Django. You can also write just don't do this, because the risk of running into SQL injection is so high, it's so easily overlooked. Don't do that, only use that language. It may be weird sometimes, but that's what you have to live with. Huh? And yeah, and if you look at the statement we are doing here, so it's basically a group by. That's how you express a group by in ORM. So that's the interesting thing here. Group by is expressed through values on the attribute and then annotate with the aggregation, which is a count. Yeah? And then there's the order by. So the order by is kind of intuitive, that I understand. Values reflecting group by, also many other things you can use values for, but this is a group by, to me, is still very unintuitive. Also there are quirks like if you sort in a different sort order, you just write a minus in front of the attribute name rather than descending. I don't know. It's syntax, you have to get used to that. Huh? But that's basically what the ORM then generates. And what might be handy is you could call this method. So if you write down a query, you can directly inspect the SQL query being issued by calling this method. And then you get this SQL command. So for learning how that works, I think it's super handy. Yeah, so how do you run this stuff? In the notebook, there are a couple of extensions you can use, but you can also do all of that from PyCharm. So the most important command is this run server command. That's basically what I did right now here. Not found, where is it? Get. How is the command? Here, that's Python 3 manage.py run server. That starts the server, and then if everything works well, you don't see any errors here, and then you see, okay, at this port on this URL, my local machine here, now if you access that, yeah, you have access to the server. And then for every request you're doing, the request is sent to the terminal. So those are so-called GET requests that are read requests. And then the system tells you what's happening. Yeah? So whenever I do something here, maybe when I now the last was 11.12, if I click here, you will see now it's 11.17. So that was this request I sent. That's basically here the suffix of the URL I was using. So you see it here on top. Yeah, that's basically the suffix being used here. Okay. Yeah, but what's really cool about Django, and that was a bit weird when I started working with that, is that Django listens to the changes in your code and restarts the server. So when developing with Django, you don't have to start the server over and over again. It's super cool. Yeah? You just save a file. Yeah, but when you modify a file, you just save it. So Django listens to the file system, to any changes, and then it will restart the server. And then might be okay that you get an error message, and then you can change it again. Eventually it will work. Yeah? But that's really super cool for development. You don't have to start the server over and over again. Yeah? But you just have to know about that because it can be very confusing. When you work with that, you also want to have a feature allowing you to inspect the database. You can have a separate it's a cool tool. It's called DataGrip, again by JetBrains, but that's all integrated into PyCharm. Again, if I haven't recommended using PyCharm, use PyCharm. It's such a great tool. Here, for instance, you have this database integration on top on the right, and then I can basically just look at the tables here and inspect any table and the data contained in that table. And that's basically the relational tables and their data contained. You can even modify the database here, which is super useful for debugging. You feel like, oh, it would be nice to have a tuple like that, and then what the heck happens with the server. That's really cool. Yeah. Okay. So what does it mean, how to use Django server from outside? You have to have something like routing, and you have to have something like views. So what does it mean? If the user performs a mouse click on the UI, as I just did in the browser on the blue text, then the UI application has to make sure that this is translated to a call to the server. And that's called a GET call. So the GET call is a call done from the application to the Django server or to a web server. Those are also GET calls. And that call will return some stuff. Will return some data. Could be a web page, but it could also be JSON. And internally, the backend application now has to understand, okay, I have a call like that with such a suffix. How do I translate that? How do I map that to a specific function? So you will have different functions in your Django server that do different things, return different types of data. And that routing happens in a file called urls.py. So urls.py is used by Django to understand how do I map this specific suffix to a specific view, a specific function in that file. And then that function is executed. It returns some data, and the data is returned all up in the stack. That's the basic workings of how this works. And this is similar in all web application frameworks. So that's the generic pattern you also have in other frameworks. There are so many web frameworks, but all have the problem that at the end of the day, you have to understand, okay, how do I map incoming GET calls to functions? And that is done through some sort of routing mechanism. So here's an example. Yeah? Here's how the urls.py file looks like in our project. And basically, you specify a path here, and then this is a function being called. So Django tries to match the incoming pattern to these paths and then executes the first found. Yeah? So this is, for instance, a home view, or this is details and search and stuff like that. And I have a those are all functions I'm calling here. Yeah? Okay. Questions? Yeah?
What's the name parameter used for? Is it just for, what's the name parameter used for? Is it just for convenience to have useful debugging messages? Or?
You mean this one? So this one, no. This can be used if you refer to such a view in your code. You can use a name parameter. I think it's called reverse or something like that, where you can look that up and don't have to specify the path again. So sometimes you're in the situation that in some part of the code, you want to reroute to a specific view again. Yeah, and then you could either specify the path or you can use that name. Wrap it with I think it's redirect or something like that, reverse or something like that. Yeah, and then you use that name, and that's super useful actually. You can also make namespaces here, so you have different parts of the application that operate in different namespaces, and then you say namespace colon, and then whatever's written here and stuff like that. You see that actually in the project that you should solve in the next 2 weeks. Yeah? So you don't have to use that, but it's useful. Okay, so what is a view? So we want to compute results to requests. The UI sends the request, hey, give me a list of all the movies. And there are basically two options we have. Yeah? So we can ask Django to return an HTML view, an HTML page, like a standard HTML web server, like in the 90s. Yeah, you type in a URL, and the web server returns some HTML. Yeah, that's the easiest way of doing that, and that we could do. We'll look at that in a moment, how that works. In the example project, also when you start the project, make sure to add an HTML. Otherwise, you wouldn't see that difference. So here, if you don't HTML in the URL, you see it here. You get something weird. I will explain in a moment. See, if you want to see the HTML version of the server, always write HTML, and then you get the HTML pages being returned. Okay. But there's another option, and that's called a RESTful server. That's also referring back to what you said with a single-page application. Modern web pages don't return HTML pages. So modern web pages are single-page applications where you once load the application, and then that application runs in your browser, and then everything else is about asking a RESTful server. You're asking a server for data. The data sent from the server is not HTML, but it's JSON. Yeah, and vice versa, if you insert, update, or delete, you also send JSON data to the server, and that's all what happens. So there's no HTML sending back and forth anymore, and that makes these web applications way more reactive and much cooler, and they look much more like native applications on the operating system. Yeah. That's the way to go. However, that's also a bit more work. Everything else we can skip over here. Yeah, in Django, it's called the Django REST framework. And our application actually uses that. You get so many, this is really cool stuff. So basically, this is what the Django REST framework returns, which is already confusing because this is an HTML web page. But we can switch here, and then we don't see anything. Maybe what are my JSON endpoints anyway? I have no idea. I showed in the project later on, maybe then it gets clearer. But basically, I can, so the Django REST framework returns JSON. So here's a simple JSON file returned by the framework. Or I can also say, that's basically some super simple JSON being returned. Or I can always say, now give me an HTML rendering of the JSON being returned. And the Django REST framework does it for free. Yeah? So Django REST framework, if you use that, you get update, insert, delete, and for free once you implement so-called serializers, long story short. Yeah? My message is, if you want to do something with a RESTful server, use the Django REST framework. It saves you tons of work, and it's really a good library. Okay, so here's how such an HTML view looks like. So basically, it's always something like, okay, there's a query set, so some sort of query that will be translated to query the database. Then there's a part that's called the context. That's some data you compute. In this case, that's actually the query result set. And then all you do in a view is something like that. You call the so-called template engine. So what the template engine is, you have a template for the HTML file you want to return, and you have some data. And those two things have to be married. You have to fill in the data. I mean, if you look at, where's the stuff? When you look at this, so at some point I have to specify, oh, there's HTML, right? It says HTML, and the header should look like that, and the table has this format and the other. So you have to specify it somehow. But in that template, I don't fill in the concrete data yet. I just have a way of specifying, okay, if data comes in, it should be displayed like that. And that's a mix of HTML and CSS, of course. And what the view does when creating such an HTML page is it's marrying the two words. It's marrying this template with the context. Maybe we can look at the template. Or do we have it here on the... Okay, do I have the template engine? Here I have it in the slides, so you don't have to switch here. So but in the slides, that's how it looks like. So basically you have some HTML fragment, and then you have a special language here, the template language. It starts with this square bracket, percentage, open, and close, and then you have like for loops and if statements and stuff like that. And that's basically saying, okay, there's a context called movies, and for each element in that context, in that iterator, in that list, you create an HTML snippet like that. Yeah, so basically this TR means you create a row in a table. This is just a table definition from HTML. And here this creates a row for each entry being found. And then you end up with a page exactly like that. Yeah, that's how that works. Yeah, so the data being returned from the query set is put into such template. Yeah, maybe we can skip over some of the details because it's right. Yeah, that's basically all that happens here. And if you do a REST framework, it works slightly differently. What you have to do here is develop or specify a so-called serializer that's defining, okay, what is the model you want to show data for, or you want to update, allow for update and delete. So basically here it's movie, and then you specify a list of fields that should be considered, and then basically you're good to go. Yeah? This plus a so-called view set is enough to teach the server to provide calls allowing you to read and change the data in the system. Yeah. You can also jump over the data here. Here's an example for that. Yeah, so this is JSON being shown in the browser. Yeah, and so the JSON is basically just a tree, and that's a tree visualization of JSON here. And the Django REST framework allows you to render that information, again, as I said, in two different views. So either the JSON representation on the left, or you can have this HTML representation also provided by the Django REST framework for debugging purposes. This is super useful. Yeah? So we're sending JSON back and forth using DRF. Another important distinction is get versus post calls. There's actually a longer list of these types of calls. There's also put calls, but it's kind of weird, this definition. So that's something defined in the HTTP standard. And basically, what you need to know is a get call is something that must not modify the database. So get call will be used if you retrieve data, retrieve the list of movies, retrieve specific information about a movie. And then you typically have a call like this. So here's your server, yeah, and then maybe here's a page name on that server, and then there's a question mark, and then you can specify certain attributes like filter conditions that should be fulfilled, and then you send that as a GET request and you get some data. In contrast, the POST request is something where you modify data, And you can split that up into put requests and delete requests if you want. We never do that, and I'm not sure why I would want to do that. So post request for you is just whenever you modify data, you change anything in the database, that must be wrapped in a post request. That would be good practice. And then that data is actually sent through a message body, and you don't see it in the URL. Maybe you can look it up here if you want for the details and how that is defined. Yeah, that's basically what I wanted to show here about Django. Well, how are we time-wise? Oh, pretty good actually. Running out of time today a little bit. Yeah. No, let's do the SQL injection and then we get that done. Okay, so before going to the project. So security in web application. So how would you approach that? Yeah. So there are two words in the security. So often it's considered an afterthought. But good practice here is actually when you build something and you know, okay, I want to put that on the internet. Today, you can't do security as an afterthought. You have to make the security by design. You have to, from the get-go, have something who is an expert, who really knows what he or she is doing, and have that person part of the project, because there's so many ways to screw up and to leave something open that people can compromise your system. The good news is Django ships with many built-in security features. Access control based on user roles already there. SQL injection prevention is there. Cross-site request forgery, and so on and so on. So it's a long list. However, this alone is not enough to deploy the Django server. So what I did here on my laptop, just by doing something like run server, what I did here was basically just this command here. Python run server, and you would imagine, yeah, I do put that on some web server and I'm good to, no, don't do that. Yeah, there are many things, many pitfalls you can run into. The one being, for instance, here's a little S missing after the HTTP, right? You want to have a little S there, so how do you do that? You need a proxy caddy or something like that. So more things you have to do here. That's something also to keep in mind. Yes, Django protects you against many attacks, but yeah, it's not that easy. Yeah? Security is a huge planet. You want to have an expert if you want to deploy that stuff. Otherwise, you might be in trouble. Okay, and the most prominent attack is called SQL injection. So the idea is if an application generates a string and then concatenates it to a SQL command string, change the string such that not only a parameter is inserted, like a constant you're comparing against, but the semantics of the SQL query are changed. So the SQL query is changed as a whole. So what I mean by that, suppose we write in Python something like that. So we say we construct a statement we want to send to the database. So this is in the world where there's no ORM. So we have an application in Python that sends SQL queries back and forth. And you want to do a filter like that. So you want to have everybody from the users table where the name equals to something that's in variable username. Yeah? That's basically how you create the statement. However, now if you set username to this string, yeah, and then you set here in this statement, this will create this string. And that means return all users where the name is empty or 1 equals 1. 1 typically very often equals 1, actually always. So that's like true. So this means return all users from the database. Okay, you see the problem? Yeah, so you specify a parameter. This was supposed to be Müller, Dittrich, Meyer, whatever. Yeah, that was what the application developer had in mind. Yeah, that's what the user will fill in. Yeah, so the username, for instance, could come from a web page. Yeah, maybe you ask for a specific movie, you ask for specific information, return the data for employee XYZ, but the user on the web page enters this string. And then all of a sudden, the database returns, yeah, basically the entire table. And this is a major source out there for databases leaking out. Yeah, it's in almost all of the cases when you Google, yeah, SQL injection again, SQL injection, SQL injection again, SQL injection again, right? And that's a problem you have to be aware of. So the major rule is never, ever concatenate strings with parameters to SQL statements directly. You must never, ever do that. That's a capital mistake. And that happens also in other layers of the system. So there are other injection attacks that have a similar flavor. That's not about SQL, but it's all about concatenating strings, where the strings semantically mean different things. Yeah, so one part of the string is query and the other is parameter. Yeah, so that's not only available for SQL. And if you look at what happens here, so that's what I'm trying to show here with this graphic. So we're mixing the query with a parameter in this world. So we have this query here, the blue stuff, and the parameter here through a string concatenation, and then we have that one. And this evaluates always to true. I'm running out of battery. Okay. But what you want to have is that you separate this parameter from the rest of the query. Yeah, those are two different worlds. So what the application developer intended, but what didn't happen was something like that, to say, yeah, that's a parameter. Yeah, but it won't change the semantics of the query no matter what you insert there. Even if you insert something like that, it's not going to change the semantics. And that can be done in all major APIs through splitting the two things. So rather than doing this here, what you did here is you create one string and then you send the string to the system, to the database system. What you should do to avoid that is you should have an API call where the two words are split. Yeah, so they have this query and you have the parameters. So the green stuff you send separately from the parameters, and then you leave it up to the database system to concatenate the two things. Yeah, and like that you don't have a single query. Like that, the database system still knows, aha, the green stuff, that's the actual query, I understand, and the orange stuff is the parameter. Yeah? So, and that actually boils down to, now the database system in this query will look for all users that have that name. That will happen with that call. So if any entry in your table, a user has such a weird name, single quote, space, or tra-la-la-la, that will be returned. But the database system will not change the semantics like done here. Yeah? And that's the important thing to understand. So semantics are unchanged. And that's how you should use these frameworks. Yeah, and there are many famous examples for that. You can also completely delete the database. With that, here's an example how to do that. So the same statement again, and now you say the username is something like that. Blah, signal score, drop table user, select stuff from foo, where, tra la la la. This will create the following string. Drop table deletes the table from the database, and that means we delete the entire users table. Yeah? If you don't have a backup, which you should, you're screwed. And there's the most famous joke in databases is this little Bobby tables. Maybe you can read that. Yeah, little Bobby tables is a fixed term in databases actually for SQL injection is kind of used as a synonym by now. Yeah, so don't name your kids like that. That's the first thing to remember. I mean, unless you're Elon Musk or so he does something like that. So sanitize your database inputs. What does it mean in that comic? So again, it's about the confusion. What belongs to the SQL query versus what is the parameter of the query? And you could now argue, okay, I have my user inputs. I could check for certain occurrences like single quotes and stuff like that. I filter them, and if I see a problem, I say warning, hey, you can't enter that. That's one way of doing that, but you can screw that up very easily. you shouldn't do that. Yeah, it's not about sanitizing input strings and still doing the concatenation. That's not a good way of doing that. Yeah, whatever you can sanitize your inputs, but no matter what you do, never concatenate the inputs directly in your application to the SQL statement. Don't do that. You should have a separate library that allows you to do that. Typical database libraries allow you to do that. Okay, I think we don't have time for that, but you can look at the SQL. We have a notebook on that. It's basically showing exactly the same thing what I just showed you. Go through that. It's really important to understand, and it's confusing to see a username like that with single quote tra-la-la-la-la, and what it means. Make sure you understand the difference in the code, but similar to what I explained in the slides. Okay, here's some links to further material. Django documentation. Personally, I have to admit I'm not so happy with the Django documentation. I find it a bit complicated or not so well explained at times. So there are many other sources. Maybe a good start is this one. Initial Django tutorial teaching you how to create a Django server, how to get started, or the real Python website is also pretty good in understanding Django, get going. Look at the IMDb example we provided you. And what we will publish today is a project. And the project is a Django application, and it's inspired by a book from a colleague of mine who's also in big data engineering, and also inspired by the famous quote from Albert Einstein. If people only talked about what they understood, the world would be very quiet. Yeah, maybe you can relate to that. Yeah, each of us knows people who talk about things they maybe don't understand too much about. Everyone has an opinion about something. Do I have to have an opinion about something I don't understand? Yeah, and so the goal of this project is to develop a social network that actually works. And it's also based on profiles. You remember I always said, oh, social profiling is bad, user profiles, don't do that. Yeah, but I also said already, no, there's one way how you could use it in a good way. And that is what I want to show with this project. Because here, in this project, you will use something that's called fame or skills. So imagine we're entering a visionary world. So this is never going to happen. Don't worry. Yeah? Or be afraid it's not going to happen. Well, depends on your opinion. Yeah? But so imagine a world where the society collects information about your individual skills on a very systematic basis. You already have that. I mean, you have a bachelor degree, you have a high school degree. That's a certificate about your skill. Maybe you have a driving license. Yeah, that's a skill. That's a certificate. That's good. Maybe you do whatever, some martial arts, and you have a black belt or something. Yeah, that's like a certificate you can wear actually for your skill. Yeah. And this fame idea puts it to the extreme. It records where you're good in and where you're a bullshitter or where you're bad in. And this information is used in the social network to mediate your posts. So if you write a post in a social network about something where you're an expert in, yeah, that's cool. Yeah? But if you bullshit, then your skill will be adjusted accordingly. If repeatedly you claim, yeah, you know, Earth is flat, and if I sail there, I will fall down in the infinite space or whatever, that will be adjusted and will be used in the social network to block your posts. So the blocking strategy for your post will be mediated using your skills. Yeah? The stuff you're good at and you have a proven record of being good at, there you're allowed to post stuff. But if you have, going back to Einstein, if you talk about things you don't understand, your posts will be blocked at some point. And that is what the project is about. So it's a bit crazy idea and a weird idea. No, it's not a weird idea. I think it's an awesome idea. But it's a bit, you have to be a little bit open to enter that world. So. And the project, okay, that's what you see when you install the project. Will be published after the lecture. Well, yeah, if in doubt, here are the credentials, if you have a worry. So that's basically, assume Elon Musk now has the idea to block bullshit. So that's one proposal. So Elon Musk didn't give me a call yet. Maybe it's going to happen one day. I don't know. Yeah? But if you look at Twitter, you see basically Elon Musk just fired the fake news team and stuff like that. Yeah? So basically that's what I have in mind, and that's a prototype of how that would look like. So I'm now the user, Tom Patterson, and here I see my timeline. And for convenience for development, here is also the list of URLs you have, the URIs you have here. But basically when you look in, that's your timeline like in the social network. You have a couple of posts. Those are posts from people you're following. You can also decide to unfollow those people. And for every post, you see the information which is actually generated by an AI, a fake AI, of course. Here it's not ChatGPT or something like that, but it could be like ChatGPT. So whenever I write a post, basically the AI will try to grade the post. It would say, oh, this is about tennis. Yeah, so that's one topic. I don't know, it's unknown. Yeah? And it's also about machine learning, and I think it's partial bullshit. Yeah? So the system will say that's not published, it's only visible for you. Yeah? So it's random, these topics and gradings, because it's just a prototype. Yeah? So whatever you write, the AI will oh, it's too much bullshit today, right? Yeah, no, that got published. So on sheep reading, it's very insightful. Yeah? And with respect to machine learning, it's mostly true. That's what the AI is saying. Yeah? Yeah, and basically the social network looks at your fame profile. So basically for every user, there are these expertise areas or skills that the system knows about. You say, oh, I'm couch surfing, I'm really a wizard. Yeah? And basically it's a subcategory of sports, foosball, table, I'm a wizard, and so forth. Yeah? And so forth, soccer knowledgeable, that's definitely bullshit. I'm not knowledgeable there. Yeah, and then you have different levels here, yeah? And basically, whenever you try to publish bullshit, those levels are adjusted. Yeah? So the system will automatically track, oh yeah, he's bullshitting again, I'm downgrading that stuff. Yeah? And so your task is to implement certain aspects of the system. So that's already the solution. So when you look into your version, without the solutions, you will also see many things happening. But for instance, you should implement things like adjusting the fame level, the skill level. Or if someone bullshits repeatedly, you should eventually block the user from the social network. Yeah? If you bullshit too much, then it's sorry, you're off. Yeah? Then you log out the system and disable the account and stuff like that. Yeah? I think it's a fun exercise. You will see how social network application, I mean, Twitter is not doing nothing except the fame stuff, of course. Yeah? And we have it split up into 3 parts. You will see we have 3 difficulty levels in the system. We also have, what the heck's going on? So because it's not a slide. So a clear description of what the state of the project is, you will be seeing. So many things are implemented. There are clear APIs and clear points in the project where you should implement stuff. And then you have different tasks and different difficulty levels. Yeah? So they're very, I hope, clearly defined. We also ran it through students and tutors who implemented that and did a lot of peer review on that. So the first level is, you will see there are a couple of unit tests, and they're failing because everything in difficulty level was not implemented in your version. So your task is to implement this stuff and make it happen. And once it works, you will see the unit tests will pass. Yeah? So the unit tests in the project, basically I can show it here in PyCharm. All tests run. Here there's 19 tests that basically check all the tests in difficulty level 1. Okay, and that's the first thing you should do, and that's also part of the grading. And then there's a difficulty level 2. You should add additional views. Yeah? For instance, there should be a view giving you, for each area, the experts. Yeah? Which users are really good, yeah? And which people are the bullshitters. Yeah? So those 2 views should be provided. You should implement follow and unfollow. And that will be difficulty level 2. And difficulty level 3 is suggest meaningful and creative extensions of the concepts and freestyle. If you feel like, yeah, that's a nice concept, but what if he did this and that? Yeah, so you can suggest something like that. Doesn't mean you have to implement all of that. Yeah, but if you have a wild idea, yeah, go ahead and submit that as well. No? Or even implement that if you want. Hand-in details, grading, basically the unit tests, you have to pass 50%, that's difficulty level 1, and there has to be a presentation in front of the tutor. They will check that you understand what you're doing. You are allowed to use ChatGPT and other AIs. However, be aware that in the presentation with the tutor, we point at some point of code and you can't explain that, then you have a problem. Yeah, it's okay to use these tools. I'm a big fan of using these AI tools, but make sure you understand what you're doing. Yeah, so if a tutor points to a piece of code and could you explain what the heck is going on, and you say, I copied that from ChatGPT. I mean, the 2023 version of that is I copied that from Stack Overflow without understanding what you're doing. It's the same version of that, right? But no, you should really understand what the heck is going on. If not, you're out. You don't pass a project and then you can't participate in the exam. Yeah? So be careful with that. Use this stuff if you want, but make sure what the heck is going on. And the best 3 projects will be presented in the lecture, actually. Yeah? So best implementations, best wide ideas, difficulty level 3, I will show in the lecture. Yeah, that's the project. Good luck with that. So no assignment sheets the next 2 weeks, just the project. Yeah? Good luck with that. See you next week.